Okay, so let's look at constructing a Taylor series for this one. We actually kind of know this one, so if you might recognize this one. So we're going to center it at 0. So again, we're going to set up our P of x. Here, P of x is equal to, figure out our A1, plug in 0, or center into our function to get A0. Okay, for A1, we're going to differentiate this. So we're going to end up with 1 over 1 minus well, in this case, it's going to be 0. Okay, so it's going to be negative 1 over 1 minus 0 squared. Okay, so that's going to give us the first derivative is going to be negative 1 over 1 minus x squared. So there it is. We should maybe put in our 1 factorial, just so we don't forget it. And since it's centered at 0, we'll just use x plus. Okay, so we're going to differentiate this function. So we're going to end up with negative 1 times negative 2. So it's going to be 1 times 2 in the numerator. And then we're going to reduce that power by 1. Oops. Oh, I forgot that there's an extra negative here. So it's going to make that a positive, isn't it? Okay, so it's going to make it positive. So we're going to end up with, when we differentiate this, we're going to end up with a positive 1 times negative 2. Okay, so we're going to have a negative out there. 1 minus 0, or 1 minus x. This is going to be cubed now. And because of that negative, we need to account for that. So we're going to use the chain rule. So we're going to do plus here, make that a plus. Okay, so then we have to make sure that we have our factorial involved in there. So this is our A2. Okay, and then put in our power series part, x squared plus. Okay, so we're going to move on to our A3 term. And I don't know if we're going to need too many more, but we'll just do one more. So we're going to end up with positive 1 times 2 times negative 3. So we're going to end up with negative times negative 3 on top. We're going to do the power rule. So 1 minus x to the power 4 now over 3 factorial. Okay, and then that's going to be, let's see there yet. Did I do my derivatives right? Looks like I did my derivatives right. Over 3 factorial times x to the power 3, the power series part, plus dot dot dot. Okay, so then I'm just going to make sure I can figure out my coefficients and I can maybe work out a formula for my coefficients. So this is going to be just 1 over 1 factorial. Okay, so this is just going to be x. And it's going to be plus. This is going to, 1 times 2 is going to cancel out with a 2 factorial there. 1, that's just going to be 1. 1 minus 0 cubed. It's going to be 1, so we're just going to end up with x squared. And then I'm going to end up with, oops, I forgot, when I differentiated this, I forgot to apply the chain rule to make that positive. Okay, because I remember I had a negative x in there. So then I evaluate 1 minus 0 to the power 4. That's going to be 1. 1 times 2 times 3 cancels out with the 3 factorial. So we end up with just x cubed and plus dot dot. This is our basic geoseries. Okay, so if you recall, if you recognize that that was actually the formula for the basic geoseries, well, then there you have it. Okay, so then when we sum this up, it's going to look like this. N equals 0 to infinity of x to the power n. And that will give us our terms. And we know that, well, I'm not going to bother doing the interval convergence for this one because we know this one is a geoseries. We know it converges for x equals negative 1 to 1. Okay, so let's do one more where this one we're going to construct. This one we don't know. Okay, so this is a function. If I were to actually have to calculate this, e is really difficult to deal with, and cosine especially, we don't really know how to calculate values of cosine. And then e to the power of these funny numbers are going to be really awkward to do. So especially the cosine. The cosine, how do you actually have a function that adds, subtracts, multiplies, and divides that calculates cosine values? So that's going to be a little bit hard. So we can try to develop a Maclaurin series. So Maclaurin series just means that the center is at 0, right? Okay, so C equals 0. Okay, so this is an easy, simple case of the Taylor series. So we're going to build up that polynomial. We're going to start with the first term. So I'm just going to plug in 0 into the original function. Cos 0 is 1. E to the 1 is e. Okay, so the second term of this is going to be when we take the derivative of that. Okay, so I'm just going to have to do the derivatives a little bit more carefully here. So I'm going to go e to the cos of c, chain rule, times negative sine of c. Okay, so I've got my derivative there, and then I'm going to evaluate, and maybe I should divide that by, so I should renumber these as well, 0 and 1, and I should divide that by 1 factorial, and then I'm going to add in my power series part, x, plus. Okay, so this is a little bit complicated, so I'm going to evaluate as I go. E plus cosine of 0. Okay, cosine of 0 is going to be 1 again. So that's going to be e. Sine of 0 is 0. So that's going to just end up being 0x. Okay, so that's a nice thing that's going to give me a 0 term. Okay, so moving on to the next one then, I'm going to end up with, so this is a2. I need the derivative of that function. Now, this is getting a bit daunting. So I don't know if I'm going to be able to generalize this, but in fact, the question doesn't really ask us to generalize. It's just asking us to generate the coefficients. So let's generate a couple more here. So it's going to be e to the cos c. Okay, that's the derivative of that, times negative sine c. Now I have to apply the product rule, plus e to the cos c times the derivative of sine is going to be cos. So we get negative cos c. Okay, so that's our second term. That's the derivative. Just use the product rule. Looks okay to me. Divide by 2 factorial, and then add in the power series part. Wow, that was a lot of work for just the first 2 coefficients. I think maybe we'll see how we go from here, but I don't know if we're going to do one more because I think the next one's going to maybe be 0. So let's work this out. Cosine of c is 1, e to the 1, sine c is 0. So that's all 0. Cos c is equal to 1, so that's negative 1. That's e to the 1, so it becomes negative e over 2 factorial. That's x squared. Okay, so maybe we'll just do one more. Although seems like enough, but let's just do one more since we're at it. So plus, well, gets really messy now. Okay, so I'm gonna have to apply product rule twice. Okay, so I'm gonna apply product rule. So I know I applied the product rule here, so I kind of know what the derivative of this is. It's just going to be the same thing. So e cos c times negative sine c plus e cos c times negative cos c. Okay, so that's the first part of the product rule. That's the first half of it, and I'm just going to highlight that. Okay, so I've applied the product rule to this portion here. It's going to end up being that. So now I'm going to do this portion here. Okay, so plus. So differentiating that's going to be e to the cos c times cos c, negative cos c. Okay, and then did this wrong.